This is CPM Precalculus Chapter 2, number 116. So here we're asked to first graph h of x, which is a piecewise defined function. The first piece is defined for x is greater than or equal to 0. The second piece is defined for x is less than 0. So you see the transition happening at x equals to 0. So let's go ahead and graph h of x. The first piece, again, for x is greater than or equal to 0 is x squared is the parent function, right? And it's shifted to the right 2 units because it's in the parentheses. So we know the parent function is x squared, right? It's just a parabola like this. But it's going to be shifted to the right 2 units. So we shift it to the right 2 units, right? And it's going to be like this. Oh, let me draw it better to the right and to the left. Again, right? But instead of going on forever, right? We want it to stop at x equals to 0. So here at x equals to 0, well, if we plug in x equals to 0, this becomes 0. 0 minus 2 is negative 2. Negative 2 squared is 4. So 1, 2, 3, 4. We know it's going to hit this point. If I can draw it neatly, that would be best. Okay, so this is a closed circle because it's, again, greater than or equal. And to the right, it's an arrow because it goes on forever, okay? So that's the first piece, and it ends here. The second piece is a line 3x plus 4 for x is less than or equal to 0. So it's the line y equals mx plus b. The y-intercept is 4. So again, 0, we get 4. And this time it's an open circle, but the open circle and closed circle together make it a closed circle. And it's a line with the slope of 3. So it's going to be going up 3 over 1. So it's going to be up 3 over 1. So from this point, it went up 3 over 1. And we're only graphing it to the left of 0. So it's going to be going like this. And it's a line like this. Okay, so this should be a straight line. And this right here is h of x, right? And it's continuous, right? If you draw this line, you don't need to ever put down your pencil, okay? So there's no holes or any discontinuities. So that's the graph, okay, of h of x. So let's go ahead and do part A. Part A is asking us to shift the graph 2 units to the left and 3 units down and graph it on the same set of axes. So 2 units to the left, right? That's basically going to shift every point on h of x to the left 2 units and 3 units down. So this point here is going to shift 2 to the left and 3 units down. So that point moves to be right here at negative 2, comma, positive 1. This point here moves, again, 2 units to the left, 3 units down. So that point's moving to here. So we can see if this point moved there and this one here, it's going to connect, right? Like a parabola does, right? Just like we have here. And then it goes to the right forever, right? Oh, I can't really draw this very well, but it's like this. This line right here, okay, so this, again, these points, like right here is moving 2 units to the left, 3 units down. So it's moving to this point. So here, again, we have the line like this, right? So in red, we have h of x. And in blue, in part B, they say call it j of x. So let's write j of x here is in blue. And again, that's shifted 2 units left, 3 units down from the original function in red. Okay. So j of x then is equal to, let's write the equation. We know j of x is equal to h of x shifted 2 units to the left. So to shift it to the left, our equation is going to be inside the parentheses, add 2. That plus 2 shifts it to the left by 2. Down 3 is outside the parentheses, minus 3. Okay? So to give the equation then, let's plug this in. It's a piecewise function with h of x being h of x plus 2 now. So instead of x, we have x plus 2. So instead of x here, we have x plus 2. So it's x plus 2, right? That's the x plus 2 minus 2 squared. and that's h of x plus 2, so we have the minus 3. And then we have 3x plus 4, and again, instead of x here, right, wherever we see x, we're going to replace it with x plus 2. So we have 3 times x plus 2 plus 4, right? That's 3x plus 4 becomes 3x plus 2 plus 4. Again, minus 3. And then, don't forget, we have the 4x is greater than or equal to 0 for x, but instead of x, again, we have the input here changes it, so it's x plus 2 is greater than or equal to 0. And here we have, instead of x, we have x plus 2 is less than 0. Okay? So let's go ahead and simplify this, because this is our equation, right? It's a piecewise function. Here, we can go ahead and remove the parentheses because it's just addition, and then we're going to have combined like terms. So x plus 2 minus 2, the plus 2 and minus 2 cancel, so we just have x left over. And x is being, in here is squared, so it's just x squared minus 3, right? And here, let's go ahead and distribute that 3, so we get 3x plus 6 here, right? And then we have plus 4 minus 3. So we can combine like terms, so 6 plus 4 is 10. 10 minus 3 is 7. So that's going to be 3x plus 7. Okay. 4, don't forget, are the regions here, what piece is defined for what region. Subtract 2 from both sides, and we get for x is greater than or equal to negative 2. And here we want to also subtract 2 from both sides, and we get for x is less than negative 2. So now in blue we should have our transition happening at x is negative 2. And here, yes, negative 2 is where the transition is happening from one piece to the other, right? So here is j of x defined in terms of x, right? And this ends for us CPM Precalculus Chapter 2, number 116.